Hello and welcome back to PC Retro Tech and our third video in the series on this amazing Tandy 1000SX machine. In this video I hope to program the graphics subsystem to see what it can really do. And I've already discovered in the manual that I overlooked one of the three graphics modes that it offers you over CGA. That's a really cool 160 by 216 color mode, which sounds great. I only overlooked it because the manual says it's only available on the PC Junior, but what they mean is other than the Tandy 1000. So I'm looking forward to trying that out. But before we get into that, guys, check out the brightness of this system unit now compared to the monitor. I did a little bit of an experiment with some retro brightening during the week. I had a couple of hours of afternoon sun and just used some generic 6% peroxide cream solution. Hobby channel rules, so I can't go into brands or anything. But yeah, put some plastic wrap over it, left it in the sun, and couldn't believe my eyes. This is probably halfway back to its original color, I'd say, just with that short exposure. Now I also did the floppy faceplate, which looks a little bit yellow still, and the mouse, it really hasn't made any difference to, but I'm totally looking forward to doing the monitor and having a second go with this. I really want to get this looking just like it was when it was bought. Well, let's get back to programming the Tandy graphics, and the first thing I wrote is not much to look at, it's just some diagonal lines, but this was just to verify that I understood the principle of operation. And if you want the technical details, you can check out our sister channel, PCRetroProgrammer, where I actually made a video, not for entertainment, just for information, about how to do this in assembly language. So basically there's just four banks instead of two, so lines 0, 4, 8, 12 and so on are all in the first bank, and then lines 1, 5, 9, 13 and so on are in the second bank, etc. And the other big difference with CGA is that there's 2 pixels per byte instead of 4. So you just have 4 bits for each color. Basically colors 0 through 15. So it really wasn't difficult to change some CGA code to work here on the TGA. Now to my eyes this actually looks like 4 CGA palette colors in high intensity and then 4 in low intensity, but if you look really closely you can see there's a yellow line there and a green line and so on. It's just not wide enough to see it clearly. So what I want to do now is try mixing TGA colors. So I'm going to do some dithering essentially and alternate between 2 different TGA colors to see if we can get the appearance of more than 16 colors on this adapter. Well, here is what I came up with. It's a grid of 256 boxes, 16 across and 16 down, and each box tries to blend 2 colors by alternating them. So one color is increasing as you go across the screen and the other one's increasing as you go down. But unfortunately, even in real life, this doesn't look particularly convincing. I'm just seeing different shades of the original colors that we started with. And I think that's down to partly the resolution of the monitor itself, and maybe just because the pixels are a little too large. And as I've mentioned before, this monitor suffers from a bit of a moire problem, which is making things even worse. So it was an interesting experiment to try, but ultimately I think although you could use these for shading objects, I don't think you're going to get a really convincing looking high color palette out of this with this technique. Well, I decided to plug in my IBM CGA monitor, and I have to say this is a higher quality monitor than my Tandy CM5 for sure. Unfortunately, it has such a high dynamic range that I can't actually capture the dark and the light parts of the image at the same time. So you might actually have to adjust your own screen brightness to see this properly. It does look better, there's no question about that, but I'm still seeing a lot of repetition in the color. I'm not seeing the wide variety of colors that I was expecting, so I still have to draw the same conclusion here. Anyway, let's move on to something a little bit more animated. And one of our viewers actually suggested that I do a Raster Bar implementation on the Tandy. Now, you can actually do 16 color raster bars on CGA, so one way that I can check that out is to see if it's compatible with CGA by running Jim Leonard's Cgi Compatibility Tester. Well, here's the Cgi Compatibility Tester by Jim Leonard, and first of all I'll try out the color compatibility. So we have the border color that can be set, and that seems to work just fine. Then we have the medium resolution mode background color, and that also seems to work just fine. Then there's the high resolution foreground color, and yep, that works exactly the way it does in CGI, so that's great. So let's try the medium resolution palettes, and well, yep, they look to be exactly the same as what you have in CGI, so it's a pretty good implementation as far as color is concerned. So now let's look at the CRT controller compatibility and see what this does. So vertical retrace should compute the vertical retrace speed for us, and look, it's 59.92 something, which is, well, close enough to exactly what it is in CGA, so no surprises there. And then we have horizontal retrace. This is where our raster bar implementation will be, so let's see if it works. And yeah, it's looking pretty good to my eyes. So it does look like you can get raster bars on this machine, so I don't need to code those up since here they are. So then we have row reprogramming. So let's see what that looks like. And really nice graphic. So let's see what happens here. I guess it's supposed to do that, I'm not entirely sure. And then the row column reprogramming. So this is the normal 80 by 25 text mode, and now we should get the 90 by 30 text mode just by reprogramming the numbers of rows and columns. So that's working exactly as for CGI, great. And there's also an interlaced video mode in CGI, but unfortunately I don't think this is going to work. Yeah, that doesn't look exactly the way I would expect, so I don't think that's supported. So there's one thing we've found so far that's not supported. Display positioning, I would imagine that's going to work just fine. Yeah, it's a little bit of flicker every now and again. I'm not sure if that's supposed to be happening. Interesting. So maybe that's not 100% right. Start address, this is a really critical one for scrolling, so let's see what happens here. So yeah, look at that beautiful smooth vertical scrolling, that is fantastic. So that is definitely supported, that's great. And then horizontal scrolling, yeah, brilliant. Now I do notice that there's a little bit of a bump when it gets to the end of its run. I think this is just because of the way the scrolling is done. I think that's actually normal, but I'm not 100% sure about that. But at any rate, yeah, it looks like horizontal scrolling is not a major problem at all. So this is actually a very compatible CGI implementation. Totally cool. Now, I'm not going to plug in a composite monitor and do all those sorts of tests and do calibrations and so on. There's other stuff here you can play with. The other thing it'll give us is a video RAM speed benchmark, but we already have some idea of how long this takes from the top bench program which we ran in the previous video, so I'm not going to go through all of these. If you have a Tandy, this is something else you can try out. So it says that 679 kilobytes per second, and the IBM CGI achieves 291. So this lines up with our expectations. Well, for a bit of amusement, I decided to put my IBM Project Chess demo on, which I wrote for the 40th anniversary of the IBM PC, and it kind of sort of works. You can see that there's a different character set in this machine, so some of the lines don't look smooth. And obviously my trick for increasing the number of scan lines in the window isn't really working. It's putting some of the scan lines at the top of the image instead of the bottom. That could just be a timing issue actually. It might even be fixable. There's obviously also a weird background color which shouldn't be there. But other than that, it's kind of sort of works. So I guess that was a bit of fun. Well, the next thing I thought I'd challenge myself with is drawing lines, and I had some CGI code for this, and initially thought that it'd be much more complex here because there are 4 banks instead of 2 in the video memory. But it turns out to not be that much more complicated. You've still only got 2 cases. You're either moving on to the next bank or you're going back to the first bank, and this is just the same as CGI essentially. So I didn't really need to make that many more changes. I picked a bunch of colours here that are not characteristic of any CGI palette, just so we can see it really is a TGA mode. And yeah, I'm getting about 400 lines per second, which is not as fast as you can go, but still nothing to sneeze at. Performance seems pretty good. So I'm pretty happy with this. I think it's time to move on to something more challenging, actually. By the way, I'm planning some additional videos later in the week on our sister channel, PCRetroProgrammer, on programming the Tandy graphics adapter. I've got one lined up on drawing lines on TGA, and I'll show exactly how I went from the CGA code to the TGA code. And as you can see, I'm taking the PCRetroTech Gecko for a bit of a spin here. This is a hacked text mode demo that I wrote some years back called a rotozoom. And basically it uses an 80 by 25 text mode, but with a quarter character height when you choose a special character with one half of it in the background color and one in the foreground color, and then you get a 16 color effect even in CGA. And so I'm running this here on the Tandy, and it's really nice that this runs without snow. It does run with snow on the IBM PC. But I'm looking at this thinking, you know, I think I can do better. In the Tandy there's a 160 by 200 graphics mode, and I don't think it would be that difficult to change the code so it works there. So obviously I'd have to change into Tandy mode 8 instead of the text mode that I'm using here. And the text mode actually only has every second byte modified. You have a character byte followed by an attribute byte repeated throughout video memory, and you only need to change the attribute bytes to change the colors of the, well, half characters or pixels, whatever you want to call them. And obviously in a graphics mode you don't need to do that. There are no character bytes. So that's one change I'll need to make. And obviously at the end of each scan line I need to change banks, since there are 4 banks in graphics mode, and in text mode addressing is just linear. So that's another change, and of course I also need to worry about the fact that the resolution is doubled in the vertical direction. If I don't make any changes at all, the image will only fill half the screen and it'll be squashed. So what I need to do is jump half as far through the image in the vertical direction than I am currently, and then double the number of lines. But those are all fairly straightforward changes to make as far as I can see. I believe that I should be able to do this, and well, I'm up for a bit of a challenge today, so let's give it a go and see what we can come up with. Well, my first attempt didn't quite work as planned. I seem to be updating the offsets in video memory incorrectly or something, but you can kind of see an image starting to appear there, so we're on the right track, I think. Well, let's see if this is any better. I found a couple of stupid bugs. I was in mode 9, not mode 8, and I was also using 160 bytes across instead of 80. Well, yeah, nothing's ever easy, is it? I don't know why I'm only getting half a screen there. That should be basically the whole screen, so that's a little bit weird. We're getting something of a rotozoom working, but obviously something's still wrong there. Well, I found another 2 bugs. One of the issues was that there's only 2 banks in mode 8, and I was using 4, so of course I was only getting half the screen filled. And another issue was that I was using unsigned arithmetic where I should have been using signed arithmetic. So I managed to fix those issues, and now something looks scrambled, and I'm beginning to think that I might have the pixels back to front in the bytes. So I'll look into that and see whether that fixes the image. Well, I think I got it this time. So yeah, in the text mode that we were using previously, there's 2 different characters you can use, and one puts the background color before the foreground color and the other one has it the other way. So when I ported over to the Tandy graphics mode, I wasn't sure which one I should be using, which of the 2 orderings. Anyway, it looks like we've got it now, and so we have a Tandy 1000SX rotor zoom working. So I'm pretty excited about the future of doing stuff on this machine. I'm sure there's other effects that I've done that could also be ported over. That's all the coding I've got time for, but I have actually been doing some more retro brightening. There's a little bit of sun this afternoon, so I got a couple hours more exposure, and I did a little bit on the monitor as well this time. So let's pull that out and take a look at how it looks now. Well, tell me what you think. Does it look brighter than it did before? It's had a few more hours in the sun, and this time I did actually do the front of the monitor. I did the system unit as well, but not the floppy drive cover this time. The mouse, unfortunately, I think that's a permanent stain. That's just not making any progress at all. There is a little bit of brightening I can see on the front of the monitor if I compare it with the parts that I didn't put the solution on. So I think it is working, but it clearly needs a little bit more, I'd say. Anyway, that's all I really have time for this week. Obviously, I'm really pleased to have a rotor zoom working on my Tandy 1000SX, but next week we have the sound system. So I'm going to try programming that and maybe see if there's a tracker available for the Tandy 1000 and see if we can pump out some tunes. So stay tuned for that. Don't forget to like and subscribe, and we'll see you in a later video. Bye.